Hey folks, welcome to another episode of ASP.NET Core from Zero to Overkill. In this episode, we'll get our whole system running with one command, making use of Docker Compose. So, in the previous episodes, and maybe rewinding to a bit of the previous ones, we have been building our application, a bunch of components, authentication, group management API, a backend for Frontend, and a single page application. We have built those components. They're not very useful at this moment, but they work. And in the previous episode, we started containerizing them to make it easy for this step that is this episode that is running them all in a single command, because we can already make them all run together, but it's a bit of a pain. And by introducing Docker Compose, we want to make it easier to get the system running quickly. So, as I mentioned, we'll take a look at using Docker Compose and run everything in one command. Other choices would be probably Kubernetes, which is the most popular container orchestration tool right now for Docker. But I feel Docker Compose is a bit simpler, and given we are only going to do this, at least for now, for a dev environment where we want to put everything running so we can check out how it's working together, it's good enough. In the future, probably we'll take a look at Kubernetes for a more production ready environment. Although Docker Compose with Docker Swarm and stuff can be used for production, it just isn't the most popular option apparently at the moment. So what we will be doing in this episode, we will take a look at three main steps. So as we'll be running in a different environment, we'll create a new app settings file for our ASP.NET applications so they can adapt. So far we only had the app settings.development.json files, which work in development. In Docker, it's a kind of a different environment, like it would be in a server for staging, for production, etc. So we'll create a new app settings files to have the specific configurations for this environment. Then we'll create a reverse proxy container to front the interaction with our applications. I will show you in a bit, but if you remember from episode 21, I show you the kind of architecture we are going for at this stage. Eventually it will change, but at this stage. And we want a single point of entry into our application, and that will be the reverse proxy. And finally, we'll create the Docker Compose file that will set up all the containers that we created on the previous episode. We'll pass them some configurations and all of that, so we'll be able to run it in a single command. So with this plan laid out, the usual plugs, if the videos are being useful, or the posts, because I accompany the videos with posts, please give it a like or share and leave feedback. Probably this one is the most important one, but the others are also nice, as share the videos, and the likes make YouTube recommend the videos to more people, I would say. And for more info, like I said, I have the posts that accompany these videos on blog.condigmilitia.com, and there's my Twitter handle if you want to discuss some things. So with this out of the way, let's go. Let me go back to the topics for us to have some guidance. And although this is the first topic, I'll just start with showing the architecture we're going for, just for us to have an idea. So you might remember this one, or maybe not, but so this is the architecture we're going for. So we'll have the application here inside this box, which will be basically the Docker Compose box network, call it whatever. And then inside we'll have each component. So the authentication, back for front, the single page application host, and the API. So the only way to get to all these containers will be through the reverse proxy. And we'll set it up in a bit. That's about it. That's the architecture we're going for. We could do something different, but it's nice we can encapsulate everything inside this network and just access through one point. Simplifies things. Okay, so let's see. Before getting here, the first topic we had planned was the Docker development. So if you remember, I'm using for example, this web frontend, the back for front, the BFF, but there will be similar configuration file in the group management API project, in the auth project, but I'll show you just one. So if you remember, we have this app settings development JSON where we have specific things. And for instance, the BFF to access the group management API uses HTTP localhost 5002. And this, I don't know if of course, but this won't cut it for other environments, if it were production, and even if it's just inside Docker containers. So I created here Docker development JSON. Some things you might not understand why are like this, but bear with me. We'll see this how through the video why it's like this. But just as a introduction, we'll be able to use names that we define with Docker Compose as the hosts, so we can use it like this. So we'll be able to go to the group management API using group management host on port 80. And for the authorization settings, the authority will be auth.playball.localhost. I can show you already that I set up, go here, I'll show you my hosts file, which is in C, Windows, System 32, drivers, etc, hosts, yes. And I set up a couple of domains in the host file, so we can have names specific for the auth and the rest of the application. So as we use identity server on a different thing, it could be like, because it's an OpenID Connect provider, it could be like an external one. In our case, it works internally, but we'll be exposing it as it was an external one. And we'll do this at the level of the reverse proxy. So even though this is not exposed, through the reverse proxy, given the host name, like normal servers and proxies and all of that, given the host name, it will go through auth or one of the others. And that's why this is here. I'll show you how we can get to these in a moment when we see Docker Compose stuff. But for now, just assume that this will be, the application will be able to reach the auth service through this endpoint, and the same for the API management. So that's the difference, and that's why we need this Docker development JSON for the application to be configured correctly for the given environment. Okay, so we've seen this app settings file. You already knew probably, because I've already made videos on these app settings files and why we use one for environment. We're just showing the changes. Now let's get to this different part, which is creating a reverse proxy. To create the reverse proxy, we have a bunch of options. We could use Nginx again as we use for the single page application, but in this case I'm going with the AJ proxy just to be different, and it's also simple to use, so it allows us to take a look at a different thing. So if I let me go here, let me go to hub docker.com and AJ proxy. So there's a container available, a Docker image available for AJ proxy with a bunch of stuff. We'll see how to use it. But basically, what we need to do, the container has everything we need. We just need to provide it with a configuration file for it to know where to route the requests as we want them to be routed, like here. Some go to auth, some go to the back for front, some go to the single page application. So we need to configure the reverse proxy to do this. And we do this by creating a AJ proxy config file. And let's go to it. So let me just show you. To handle this part of the Docker Compose, I created a new repo deployment, and it is here at the same as a sibling of the other ones. This is important because I'll be assuming that the other repositories are siblings, so it will be able to find the files to be able to create the Docker containers for that. In here, in the deployment, I created a Docker folder. Right now it's the only thing that it has besides the usual license and readme. And in here, besides this Docker Compose dev, which is the file we'll work later to configure Docker Compose, I also created a folder for the reverse proxy. And in here we have a Docker file and the AJ proxy config file. So let's take a look at this config file. I'm in Visual Studio Code, and that folder in the reverse proxy, I already have some things in there in here because they are usual defaults that one copies from somewhere. Probably in production, of course, this is important. In this case, as I'm just going to have this working in dev, we can jump, but just a quick look. So some global configurations. We want AJ proxy to run in daemon mode or in background. We are setting maximum connections. Again, in dev, this is really important. Defaults are some default settings for AJ proxy, so it will work in HTTP mode. An alternative would be work in TCP mode. The main difference is that in TCP mode it wouldn't inspect the HTTP headers or the payload. By inspecting the HTTP payload, we can create rules for proxying, and we'll be using that. So we can't use TCP in this case, but of course if we could use TCP, it would be more performant because it didn't have to inspect the HTTP traffic. And then some timeouts, some default values. Again, in production this should be better configured. In my case, I copy pasted these values from somewhere, and for dev, good enough. So let's start configuring AJ proxy. To configure the proxy, the main concepts we need to know are the concept of frontend and backend. So frontend is something we define in the proxy as a way to have incoming requests. So for instance, we can register a frontend on port 80, and then in that frontend we'll have logic to tell the proxy for which backend to route the incoming request. And the backend will have some rules to map to really specific services inside the network, like we'll see. So we'll start with the frontend. To configure frontend, we put in frontend and give it a name. I'm going to call it public. And yeah, I'm not doing this by heart. I have some cheats on the other screen, so don't think I know this all to write it this fast. So we'll create a frontend public, and then we can do something like bind to port 80. Right now, only binding to port 80, not worrying about HTTPS yet because we're in dev, but of course that's mandatory for production stuff. So we're defining the front end, which will listen on port 80. Then we have to configure rules to handle the incoming requests. We can define these rules by using ACLs, and we can use like named ACLs that we can reuse in multiple places, or we could just use the ACLs directly when saying to which backend to route. I'll start with a couple of named ACLs because they can be reused, and then use the other ones. So create an ACL named host main, and this will match the requests that are for the main part of the application, so or for the single page application or for the BFF, which will be the main recipients of the requests. Then to split the traffic, as we seen in the host file, we'll use a couple of different hosts. One is PlayBall localhost for all the requests, except for the auth service. For the auth service will be auth.playball.localhost. So to check this out, we use HDR and say host. And this means we want to get the host from the header, and then -i means we want to do a case insensitive comparison with what comes next, and what comes next is playball.localhost. So this rule means host main will have the header equal to playball localhost. Then we'll have another rule for the other host, which we'll call host auth, which will go to the header host and compare with auth playball localhost. Okay, so we defined a couple of rules to match the headers, and now we can use them to define where the incoming requests are going. So again, in the front end we choose which backend we want to forward the request for. We do that by using use backend, and in here the order matters because the first rule that matches is the one that the request is forwarded for. So we'll say that use backend auth if host auth. So if this ACL matches, go to the auth backend that we'll define later. Then use backend BFF, which we'll also define later, if host main, and the end is implicit. We can put in here path bag. Of course there's documentation for all this stuff. I'm not going through the documentation because I already went through and created my rules. And if the path begins with API, if you remember, we did this in the configuration of Vue.js in development, for the development server to forward all requests starting with API to the backend, be it the BFF or the group management API when we started. And that's, and just to as a reminder, that's why we need this in HTTP mode, because we need to inspect HTTP payload to go into the headers or to go into the path. And finally, we can use backend single page application if host main. And remember, the order is important. If I did this, it will always go into single page application because it would match host main. But because I'm doing it this way, if it is host main and starts with API, it goes to the BFF. If not, goes to the next rule and goes into the single page application. If matches the host, of course. If we just make a request like localhost, it will, the AJ proxy will return a 503, I think, saying that we can process that. Okay, so that's it for the front end. Now let's take a look at the backends. So these backends, auth, BFF, single page application, we need to configure as well. So we go here and we'll create backend, and give it the name single page application. And then we configure what we want in there. So by saying server, we'll say the server to which to forward the application. We can give it a name, single page application 1, and then say where to forward the request for. So single page application 80. This is the host name. Could be an IP, so it could be something. In this case, we can use the host name because Docker Compose will provide us with host names, like I mentioned in that Docker development app settings file. So this is the same. So SPA will be the host name of our single page application. Then we can configure the other ones. So backend auth. Oh, it's just another point I was forgetting. We give it a name because we could have, for instance, AJ proxy can also act as a load balancer. So imagine we could have here in a different IP for some reason, and this would be, and this would basically act as a load balancer. It's not the case, so we can remove it. Back here, I'm adding this here, forward for. So basically this will include a forward for header with the IP, the original IP, so the server knows the original IP of the request. And this will be the same, server auth1, auth80. And the same for the BFF. Just copy our server. The same. For the configuration and routing for our services, this is all. I'll just add something here. Let me copy this. and I'll add this here. So we can expose, and that's what I'm doing. So listen statistics and bind to port 81, and this stats means we want to use AJ Proxy's, how is it called, statistics endpoint. So there's a page available. Probably this isn't good to expose to production, but it's nice for us to see here in dev. And this will be, so if we go to playball.localhost/AJ Proxy, or better yet, playball localhost port 81/AJ Proxy, we'll be able to see a page with the information about the work of AJ Proxy. We'll see it in a bit. Okay, so this is the configuration file. It isn't really the focus of this episode. It should be Docker Compose, but given I'm using it, it's something more we can learn. So we have the configuration file, and we use a Docker file. So we create an AJ Proxy container image based on the original one, just to config the configuration file, just to pass in. So we're just copying the configuration file that's already here into this specific path inside the container. Other alternatives would be to have a volume with this configuration file and just run the AJ Proxy container or the original and pass in the volume with the, and map the volume with the configuration file, but whatever, it's the same. So I just created a new one. Probably it's not the same because by creating a new container, it's maybe slower this way, but we're in dev, we're good. Okay, so that does it for configure AJ Proxy. I probably went a bit too fast, but hopefully you can get the picture. It's not the focus of the episode, but just nice to know. So this is done. So we can go to Docker Compose. I created this file already. So let me get back to the plan. We've seen the app settings file and created a reverse proxy, even though a little on the quick side, but there are probably better introductions to AJ Proxy and stuff like that. This was just an excuse for to use it. So now let's get into the important part of this episode, which is create a Docker Compose file. So Docker Compose, let me go here, the docs, and if you read a bit, is a tool for defining and running multi-container Docker application. So we use a YAML file and configure the application services, which is the name they give to every component. And then with a single command, we can run it. So a YAML file. I went ahead and created already the YAML file, Docker Compose dev. If we just called it Docker Compose without the dev, we would be able just to go to the command line and do Docker Compose up. Because I put the dev, it will need for us to provide the name of the file, but it's just to make sure it's understood that it's for dev. So, like I did for the reverse proxy, I will follow my sheets, but all the information, if we go here besides the Docker Compose, we have the Compose command line interface reference and the file reference. And in here, you'll find we can see here all the commands that we can use on the file, although we'll skip it and just go into it. So the first thing we put in the compose file is the version we'll be using. I just use the latest, so there are 3. What you can just put 3 and it will use the latest version of 3, I would say. and then we can start defining our services and other stuff. Just to make it clearer when we use it, instead of starting with the services, I'll start with the networks. So we can define networks that will be used by the containers to communicate, and we'll create just an internal network, use whatever the default is. What we want is all the containers to be inside the same network and be able to communicate using their names. So that's how that thing I showed you, for instance, here in AJ Proxy. So the reverse proxy, which will be inside the Docker network, will be able to go to the single page application, auth, or the BFF just by their names, because of being inside the same network and having an internal DNS, I would say, so they can resolve each other's IPs by name. Don't know exactly how that's implemented, but it works like that. Okay, so with the networks, which is really simple what I defined, there are options, but for me the defaults are okay at this point. We can start defining the services. The services is where we actually set up the various containers we'll be using. So let's start. We'll start with the reverse proxy, which is right here. So we'll call it reverse proxy, and then we start configuring it. As we will be creating, it's not a pre-created container that we'll just download from a hub. It's something we need to build, so we'll use the build command and we'll build reverse proxy. This is the path. It's right here, so it's right in the next folder. So this is the path. And the image will be named coding militia / reverse proxy latest, because reasons. Then we can set up some more stuff. We'll set up ports. We'll say we want to map port 80 to the host port 80, and the same for 81. As you saw, it's the ports we want to expose from the reverse proxy, and these are the only ports that we'll expose. So these ports that we put here are the ports that we want to expose to the host machine. So the only ports that will be exposed are the ones from the reverse proxy. All the other containers don't need to expose the ports, because they'll just be used internally, and internally they can access each other's ports. We just don't want to expose them to the host. Then we can define the network, and we want internal network. So we'll be using the network we created above. And then we can put here, it's not mandatory, like many things, but there's an interesting stuff that depends on. And this will tell compose that this reverse proxy depends on other containers, particularly single page application, BFF, and auth. This is good, but it's not good enough. Hopefully we'll get by with just this. So this means that the reverse proxy container should be started after these are started. So this is good. Why is it not enough? Because, for instance, just because the BFF container is up doesn't mean that the BFF service that's running inside of it is really ready. So the ASP.NET application might be starting, even though the container has started, and Docker will know, oh, the container is up, but it doesn't know if the application inside is already available to handle requests. So if, for instance, this takes too long to start, the reverse proxy could fail because it would try to access the BFF or something like that, and it would fail. So this is good, but maybe not good enough. But for production scenarios, we have ways of making retries and stuff like that. Well, I'm just not going to do that here, but there are workarounds for production stuff. Just not worth it right now. Okay, so this does it for the reverse proxy. We can now go to the next one. So let's go here. This is the pane of the YAML files to get the tabs correctly. Okay, so the single page application. Now this will be very similar to the above. So we'll need build, and we need the path. If you remember, the path is, we are here in Docker. So we'll need to go back once to go to deployment, once again to go to here, then we need to go forward. So once, twice, then web frontend, client, and here. So this is a path to build the image. That's where the Docker file is. Then the image, we'll call it coding militia / web frontend / single page application latest, because why not? And then let's just copy this. This depends on this, depends on, and the single page application depends on the BFF. Now this isn't really useful because the single page application can be running without the BFF. It won't, or the container won't have any problem by being running before the other one. It's just more in terms of semantics. Single page application without the BFF doesn't work really. So I'm putting this here. But in terms of containers, this is useless because the single page application is serving static files. It doesn't need the BFF for nothing. And the single page application is done, simpler than the other. And as you see, no ports because won't be exposed outside of the Docker network. Now for the BFF, I'll just copy paste a bit because it's the same. It failed completely. So this is the same. We'll just add one more thing. Okay, so this is basically the same. We're saying where to build the image, from where, what's the name we want to give it, the network, and depends on the root management service. But now we'll add something extra, which will be environment. And this is where we can define environment variables. If you remember from the beginning of this episode and from the configuration episode, this, for us to get to this development or Docker development, it's can be passed in a couple of ways, one of which is an environment variable. So we want to have an environment variable which is ASP.NET Core environment, which will equal Docker development. And this will tell our ASP.NET Core application that we are running in Docker development environment. So it will make use of the correct file in this case. And even inside there can be, I don't remember if I put something in here. Probably not. May see, nope. But for instance, where is development, we could have or env is what was it? Or equals could also do this. But for now, all we want is to select the correct settings. So we'll have something like this in all the ASP.NET Core applications to use the correct settings file. Now for the others, the group management API and the auth, I'll copy group management because it's exactly the same. I don't know why the tabs are all weird. So group management is exactly the same. Where to build it, image, networks, depends on stuff. Now for the auth, it will be the same for a bit. So I'll just copy 1 bit. So here is where something is different. Let me put just this here. I'll copy just the rest. So the same as here, depends on, so this Postgres, we didn't start it yet, but we'll have the database as well. So all the same, but the networks in here will be just slightly different, and I'll explain you why. So in here, it will have internal network, but instead of just saying that we have internal network, we'll add an extra configuration, which will be aliases. And here we'll put auth playball.localhost. Okay, and why is this? And I'll just copy paste the comment I have here, and you'll maybe understand immediately. If not, I'll explain. So this is a trick to be able to access the auth service from inside and outside the container network. Why is this? Let me go back here. If you notice, for the authority, we're using not auth. For instance, here we are using group management, but here we're using auth. We're not using just this, which probably is what we expected, given what I talked about, the DNS being the name of the container and all of that. This has a problem, that this will work as long as it's the container making the request directly to the other. The problem is that we want to use this auth service also outside of the container network, because we need to do the login, we need to go to the Razor Pages application, do the login and stuff like that. So the BFF will eventually make a redirect to the auth service. The problem is, if we just put it here like this, the redirect will be to this place, and we can't access this from outside the network. So to go around this problem, we can use the public DNS, which is this one. For instance, if we had the auth service completely independent in a different environment, we could of course use its DNS to go there. In this case, because we are hosting everything together, we will also use this DNS, but with the difference that I'm putting here as an alias. So we can access the auth service given its name, so just auth, or an alias, so the auth PlayBall localhost. This way, this is why this works. In here we have backend auth, so the AJ proxy can forward it using the basic name, but in the configuration for the BFF, as we want the redirect to work correctly, we use the complete name, so we can access internally through the internal DNS resolver for Docker networks, and externally because we'll be redirected, and we have this in the host file, or we could have a real DNS name purchased. In this case it's just a host, but that's why we have this trick, and that's why this is different from that one. We use the alias for the authority to be able to be used internally and externally to the Docker network. That's why this exists here, and hence the comment. So we have our components all set up, but we need the database. So this will be slightly different, but very slightly. So we'll call it PostgreSDB, like easy. And then image is just Postgres, because we don't want to go to it's not something local, we'll download it, so we don't need the build stuff, we just need the image name for it to download. And then the rest is the same: networks, internal network, and a couple of environment, and this will be Postgres user, which will be our super secret password, and user. So if you remember, it's somewhere, maybe here. Where did I put it? Oh, this is the BFF, doesn't have it. Let me just open this real quick. Can be in the same window eventually. Come on, why? If we go here to these settings, so the connection string, server PostgreSDB. If you remember, in development it was localhost. In here is PostgreSDB, port stuff, and user and password like this. Of course, in production it shouldn't be here. We should be using some secrets or environment variables not set in a compose file, but we're not in production, so no issue. And this starts the Postgres. And that's it for the Docker compose file. Now we can get it to run. We can get it to run, hopefully, if this works as we expect, of course. So we are in the correct folder. Now we can do Docker compose and give it the file. If we do just docker compose up, can't find the file because it's expecting to have this name. As we don't have that name, we need to give it the file name and docker compose YAML up, and I'll add a couple more flags. D to run in daemon mode. If we don't put this, it will just run in the foreground. And build, if I remember correctly, we can check out here, docker compose, clear reference, build, which means we want to build or rebuild the services when we run it. We don't want to expect them to be I think if I don't pass this, it will build the ones that are not built, but if they are already built, it will not rebuild them even if they change. And I want it to rebuild when we are in development. If we are making changes, we want it to rebuild for us to get the changes. So I want the build flag, and let's see how this goes. Hopefully it won't take too long. Wow. Line 50. What's in line 50? 50. Depends on PostgreSDB. This is wrong? Why is it wrong? What's the error? Weird. Let me check for this. What about now? Okay. Some weird tab and stuff because YAML is this cool. Okay, downloading stuff. Hopefully this won't take too long. Didn't remember I deleted all the images. Just for everyone to not be sticking here, I'll pause the video for a bit and get back when the download is done. Back, and the download is done. Now extracting. I think the .NET SDK is the biggest download, so you can see all the rest going. The other images should be fast to download, hopefully. I just don't want to edit the video. Or better yet, I want to edit the least possible. So let's see. Build image, building. So this one is faster because it's the Alpine image, which is much smaller, not the gigabytes as the other one. Now the other containers are faster because they all, except for the node ones, are based on the same SDK and image, runtime image, so it's faster. Fortunately, .NET Restore is not terrible. So I've seen group management, auth, and BFF, I think. Now the single page application. And probably Postgres already started. or not. Oh no, this is just building the images. It will start everything at the end. This one is not as chatty as the other ones. Okay, Alpine. The node image is probably smaller than the .NET one, so not too bad. I should have the images cached before recording a video. Damn it. Okay, some warnings. Eventually I'll fix that. Oh, come on. 256 vulnerabilities. Sheesh. Okay, Nginx. Copying that, the web frontend, and this AJ proxy, so we're almost there. Finally, running the containers. Postgres, auth, group management. Yay! And now Docker, PS. And it's all up. Nice. So, if they're all up, just one point that might come in handy. If for some reason one is not up, we can do A to show even the killed ones. And then we can, if we want to look at the logs, we can do docker logs, and for instance docker bff1, and we'll see what's in there. And you might find this familiar. It's the usual logs from ASP.NET. Okay, so this seems to be working. So let's go to the browser and go to PlayBall localhost, and the application is running. If we go here, let's see the logs for Proxy. What's his name? Okay, not really great, but if we go then, let's go to one of ASP.NET, so BFF, we can do, what was it? F follow, so we'll see the requests coming in here. We can log in. It will go to PlayBall. We should have logs here. So authorize, filter, challenge. OpenID Connect was challenged, so it went back to did the redirect. And over here, there's no one, so register a new user. Test at test.com. Prefix. Register, and we're here. And if we go to the groups, there should be a request to groups. Exactly, groups controller, get all async stuff, so you can see the logs. Everything is working. You can create a test group, save, it's here, go home, go to groups. You can see there's requests going on about groups, and it's working. As we already saw the application working, of course, but it's working inside Docker. And if we want to get it down, we just do down. I think it's the command. Yes, it stops everything. Why does it take so long? Okay. Remove the containers, and we go here and we get nothing. Let's see, .ps, hey. So all the containers were removed. We can, where was it? Go for it again. It builds the container images again because I'm passing the -- build, but it's much faster because all the cache of the containers, just creating them, and we're back. Need to log in. The database, probably, exactly. The database was also removed, so we need to register again. But we're back. Okay. Cool. So we got it working. So just a quick recap. We started by looking at the app settings file where we had those changes regarding mostly the endpoints, which are the names we are defining in the Docker Compose file. We created a reverse proxy so we could achieve this architecture by having just one entry point into the Docker network and everything hidden behind it. And we created the compose file where we orchestrate everything. We say we want this service and this one, and depends on each other and the configurations and all of that. And in the end, with one single command, we were able to run everything. So makes testing the application much simpler than having to go to each folder and starting the project. Hope you enjoyed it, and hope to see you in the next one. See yous!